How do you use the definition of the derivative of a function? You insert the given function into the definition and evaluate the expression to find the derivative. Let's look at an example. You will find the derivative for the function f of x equals x squared. You start by inserting the function into the definition. Notice the independent variable, x, in the function. As a reminder, the independent variable of a function is the variable you put into the function, often known as the x, while the dependent variable is often known as the y. Take a look at the definition of the derivative. Here, you will see that the independent variable is x. However, in the numerator of the first expression, we add a delta x to the independent variable. Both of these terms need to be substituted into the function that you want to differentiate. Let's take a look at how this is done. First, we'll examine what x plus delta x would look like when inserted into x squared. Since the x is squared, you can imagine that there are invisible parentheses around the x. Now, you need to remove that x and replace it with x plus delta x. It can be a little confusing that there are several x's, but you can think of them as two different friends with similar names. The second expression in the numerator is just f of x itself. So, here you can just write x squared for f of x. Now, you substitute the expressions into the definition. So, f of x plus delta x will be substituted with x plus delta x squared. The minus sign stays the same, and x squared is substituted for f of x. In the denominator, delta x is always left as is. You are now in a position to evaluate and simplify the expression. You can use the square of a sum formula to expand the first term in the numerator, to get x squared plus 2 times x times delta x plus delta x squared. Then you complete the numerator by writing minus x squared, which is already there. The two x squared terms cancel each other out, so in the numerator you're left with 2 times x times delta x plus delta x squared. Delta x is to be viewed as a single quantity, which is also a factor in both terms in the numerator. So, you can use factorization to put the delta x outside of parentheses. Now, the delta x in the numerator and the one in the denominator cancel each other out. You are now left with the expression 2x plus delta x. As you can't simplify any further, you have reached the step where the limit comes into play. So, what happens to the expression containing delta x when you view delta x as 0? Well, adding 0 gives 2x. Consequently, you have reached your answer. The derivative of x squared equals 2x. You have found, using the definition of the derivative, that for the function f of x equals x squared, the derivative f prime of x equals 2x. Let's look at another example. You will find the derivative for the function f of x equals 4x plus 2. First, let's take a look at what x plus delta x would look like when inserted into 4x plus 2. Since the x is multiplied by 4, you again imagine that there are invisible parentheses around the x. You need to remove that x and replace it with x plus delta x. Again, it can be a little confusing that there are several x's, but keep thinking of them as two different friends with similar names. The second expression in the numerator is just f of x itself. So here, you just write 4x plus 2 in place of f of x. Now, you substitute the expressions into the definition. So, f of x plus delta x will be replaced by 4x plus delta x plus 2. The minus sign stays the same, and 4x plus 2 will be substituted in for the f of x. Remember to include parentheses around 4x plus 2 so you don't get in trouble with the signs. In the denominator, delta x is always left alone. You are now in a position to evaluate and simplify this expression. You expand the parentheses and get 4x plus 4 times delta x plus 2 minus 4x minus 2. The 4x's and the 2's cancel in the numerator, leaving you with 4 times delta x. So now, you have 4 times delta x over delta x. Like before, you cancel the delta x's. You're now looking at the limit of 4 as delta x approaches 0. There are no delta x's left in the expression, so the delta x does not change the expression's value. Therefore, the limit equals 4. You found that using the definition of the derivative, that for the function f of x equals 4x plus 2, the derivative f prime of x equals 4. You use the definition of the derivative by inserting the given function into the definition. You then evaluate the expression to find the derivative.